Okay, so now we proceed to another information in terms of the introduction to the chromatography, which is regarding the chromatogram or data that we obtain from the chromatography. Okay, so basically this is a chromatogram, so you have to really understand when we talk about the time, and also there are several information that you can obtain from the peak. Okay, so because some simple calculation will be related to this simple information that related to the chromatogram. The first one is the retention time. So usually the retention time will be given, right? But you have to really understand what is the retention time. So basically you know that how much the analyte retain in the stationary phase during the separation, right? When you have this kind of the chromatogram, so you know that compound C, okay, having more retention time, so it will be it retain more in the stationary phase as compared to, for example, you have compound B here. Compound B having the we call it as a less retain in the stationary phase, so that's why it coming out first and then it will be detected eluted first. Okay, and then you have WB. WB is a baseline weight of the peak, right? So this one is related to the baseline. So this is WB, so it can same goes to here and also here. So usually when you are using HPLC and also GC, sometimes this is we can get from the system. But for example, in the exam, usually this information will be given. If you have to calculate it on your own, so usually the chromatogram given is very clear, so it's easier for you to do the we call it as having the scale and so on. And then another information, you have a WH. WH is half, okay, height width of the peak in time unit. So here, so you have the peak, and then peak height is like this, and then this is half. You can calculate the WH. Same goes to here. Okay, for example, in the exam, this information will be given if it is related to the calculation. Okay, for example, you have two chromatogram, and then you know that there will be two compounds need to be separated. From here, you can see that this first compound is well separated, right? Or in another word, this is very good separation, right? And then you have this one, as compared to this one, they are overlapping to each other. You know that there will be two compounds, but due to the, we call it as a very bad separation, so you cannot determine in detail what is the, for example, the baseline with WB, WH, and so on. From here, it's quite clear to see the first one is very good data, which is well separated. This one is a very bad data, which is not separated at all. So if you are having this kind of problem, so you know that it's easier for you to detect. But how about if you are having this kind of the chromatogram? Okay, for example, you have this one. You know that you can see that two peak, right? But sometimes you can say that it is not separated. This is separated, you didn't know. Okay, so of course from this one you have to do the calculation to confirm that is it we call it as two compounds already separated or not. So this one, this is a calculation related to the resolution, which is we use RS. So what is RS? Basically the resolution between two peak is a second measure of how well two peak are separated. Okay, so how do you calculate RS? So basically you have TR2. What is TR2? Which is any retention time from the peak 2 that having more retention time lah. And then minus the retention time for less than this one. Okay, for example, if you're having peak A and also peak B and also peak C, you only can measure the resolution between peak A and peak B and also peak B with the peak C. Okay, so you cannot say that I want to measure the resolution between peak A and C. Cannot. Okay, so for example, you have the retention time here. Peak A is 1, peak B is 2, peak 3 is C. So when you relate with this one, TR2 means, for example, you want to look at RC, RS between peak A and also peak B. So you know that TR2 is referring to the 2 here, which is having higher number, right? Minus TR1, 1 here is referring to the A. Okay, so I hope that you are clear with this one. Over, same goes to here. You have WB, which is the baseline width, which is B is referring to the peak B, okay? And then you have to plus WB1 is referring to the peak A, and then you have to over 2. From that, you will obtain the value of RS. Okay, so I hope that you can find the question from the internet, or you can do the tutorial, okay, the question in the tutorial. So it's quite easy to understand based on this one. Okay, but if you calculated the RS and then the value obtained is 1.5 or more. Okay, RS is 1.5 or more than 1.5. So you know that you can make a conclusion that these two peaks are well separated. Okay, so this is an example. For example, you get 1.5, you can see that these two peaks are well separated. But if you are having RS which is between, right, 1 until 1.49, for example. So this one is already separated, but it is not well separated. Okay, almost separated. As we can see here, this peak A and peak B, okay, baseline dia pun tak berapa clear as compared to this one. So you know that consider educate for more separation. The separation is almost happened. Okay, maybe we can try to adjust some things, for example, here and there, so you can obtain the best resolution. But if you are having two peak and then the resolution is less than 1.0, which is, for example, 0.75, so this is no choice, this is very bad data. So that means these two peaks are not separated at all. So as you can see here, so you cannot proceed with this data. Okay, so this is the calculation on the resolution. Another calculation, which is we only have two calculation in the chromatography. The one is resolution. The another one here is a plate number. So the plate number, basically this is a theoretical, the conventional theoretical that come out from the first inventor of the chromatography. So the researcher come out that N is equal to L over H. Okay, so this is referring to the column, the stationary phase, which is, for example, if you are having N is a plate number. So plate number here is equal to N. Plate number is higher, so you know that the separation happen is higher. In another word, if you want to obtain greater separation, so that means you have to make sure N is higher. Okay, while getting N higher, so you know that you have to decrease the value of H, which is the plate height. Okay, but from this information, you know that it's very impossible for you, okay, to calculate L and also H based on the column. So kita tak tahu column panjang mana, panjang ni ke, height dia berapa dan so on. So that's why to get more understand on the plate number, so another calculation is occur, which is based on the chromatogram. Okay, so you calculate N is equal to 16, TR is the retention time over WB. Here is referring to the WB, baseline, and then to the power of 2. Okay, from that you can compare the value for N. So from here, you know that to calculate N, so each of the peak have its own N. So N dia berapa, for example, N dia berapa. So it different with the resolution. Resolution is you want to compare two peaks that are nearest to each other. Is it well separated or not? From N, each peak should have its own plate number. So based on this calculation. Okay, for example, this is a very simple question to calculate N. For example, you have two peak. Okay, the width here, the baseline, which is WB, is equal to 4. And then the retention time for the first one is, we call it as the 49 minute. And then another one here is 1 to 7 minute. Okay, so the question asks you what width is expected for a band with a retention time of 1 to 7. So the question asks you to calculate what is WB for this peak. Okay, from the same analyte mixture on the same column. So what you have to do first, you have to calculate N for this one. Okay, so N is equal to 16 TR over WB and then to the power of 2. Okay, you already have the information of TR, which is 49 minutes. What is WB? WB is 4. Okay, and then the value of N will be obtained. Okay, from that to calculate the WB here, so it's very easy because N is already obtained from this calculation. Okay, and then the 16 and then TR is given, and then from that you automatically you can calculate WB, right? So it's quite simple. Okay, so I think that's all for the calculation for the chromatography. So usually when we go for the HPLC and also GC, if any calculation asked in the final, so it will be similar. So regarding the resolution and then how about the plate number. So when the question coming out which is related to the plate number, so if there is no calculation involved, so you have to go for the theory, which is N is equal to L over H. So you have to explain what is N, okay, how to get the higher N, okay, by adjusting the L and also H. That's all. Okay, so thank you very much